What is up, pre-calc? This is lesson 8.3. We're just doing the first part of it, so I'm calling it 8.3a, and we're just talking about dot products today. And dot product is a new type of operation that we use with vectors. Since we don't have normal multiplication, we have what we call a dot product. And the dot product is defined like this. If you have some vector A that's A1, A2, and some vector B that's B1, B2, and the dot product between them, symbolized with a dot between the two vectors, is A1 times B1 plus A2 times B2. Now notice this does not give us another vector, but a number. So this does not give us a vector, it gives us a number. So the dot product of a couple vectors is a number. Now when we're talking about two vectors, if these vectors are perpendicular to each other, then their dot product is going to be 0. And when their dot product is 0, we call those orthogonal. So that's one of your words that you need to learn for today is orthogonal. Okay, orthogonal just simply means that they are perpendicular. And you know that if their dot product comes out to be 0. So for these ones here, 1a and 1b, we're going to try to do one of those. Since we want the dot product of u and v, I'm going to say 3 with a pen instead of a highlighter. 3 times negative 5 plus negative 2 times 1. So this is going to be negative 15 plus a negative 2, so it's going to be negative 17. So is that orthogonal? No, because it's not 0. So I'm going to say not orthogonal. Let's try this next one here. Again, so we're going to say negative 2 times 9, so negative 2 times 9, plus the negative 3 times negative 6. So negative 2 times 9 gives me negative 18. It's going to give me positive 18. When you add those together, that gives me 0. So the dot product is 0, which means that it is orthogonal. Alright, so here's some properties of dot products. There is the commutative property, so u dot v is the same thing as v dot u. Also the distributive property of taking u dot the sum of 2, like v and w, that's the same thing as u dot v and u dot w. Also, if you're taking the dot product of two vectors and you're multiplying that by a scalar, that's the same thing as multiplying the scalar times one of them and then dotting the other one, or scalar times the second one and dotting it times the other one. Either way. If you have a 0 vector represented by the 0 and you dot product with anything, it's going to give you 0, which kind of makes sense because both the A1 and A2 would both be 0. And then this is the cool one here, is that if you dot any vector with itself, that's the same thing as the magnitude squared. So this is another way that you can find the magnitude of a vector. It's just by taking the dot product of it with itself and then taking the square root, which is what they're asking us to do here. So we're just going to take the dot product of it with itself. So it's going to be 12. I don't know why I put the. Sorry, it's going to be 12 times 12 plus 16 times 16. So it's going to be 144 plus 256. So that's going to be 0, carry the 1, 0, carry the 1. It's going to be 400. And then I need to take the square root of that. So the square root of 400, right, because it's squared. I just want to know the magnitude, so take the square root of that is going to be 20. The next thing we're going to do here is find the angle between two non-zero vectors, a and b. So if you have two vectors here, both starting at the same point, this angle over here is b minus a. This angle between them is the angle theta. Cosine of theta is equal to the dot product of a and b divided by the magnitude of a divided by times the magnitude of b. So let's go ahead and try one of these here. So we knew that cosine of theta is going to equal to the dot product of these two. So in the numerator, I'm going to have negative 5 times 4 plus negative 2 times 4. And then on the denominator, we need to find the magnitude of a times the magnitude of b, which is just going to be the square root of negative 5 times negative 5, so 25 plus 4 times the square root of 16 plus 16. So this is going to be negative 20 minus 8 on the top. It's going to be the square root of 29 times the square root of 32, which is going to be negative 28 over the square root of 928. I just multiplied the 29 and the 32. And then, so this is cosine of theta. I want to know what theta is. So theta is going to equal to cosine inverse of that number, negative 28, over the square root of 928. And if you plug that in the calculator, make sure you're in degree mode, you get 156.8 blah blah blah, but we're going around to that. So theta is equal to 156.8 degrees. We'll go ahead and do one more of those just for fun. So we're looking for the angle between these two vectors. So I'm going to say cosine of that angle is going to equal to 9 times the negative 6 plus 5 times 7 over the square root of 9 times 9, which is 81, plus 5 times 5, which is 25, multiplied by the square root of negative 6 times negative 6, which is 36, plus 7 times 7, which is 49. This is going to give me negative 54 plus 35. So on the top, those are subtracting. I believe it's going to give me negative 19 over the square root of 9,010 when I multiply the 106 times 85. This is what cosine of theta is equal to. So to find theta, I'm going to say cosine inverse of that thing. And you get 101.5 degrees. And that is the first half of the lesson. Your homework is on page 506. You're going to do 2 through 22 by 4s. Good luck, guys.